Why do we need to think about converting from one unit to another? Well, even if you don't bake, you're probably aware that a recipe tells you both what should go into the meal and how much of that ingredient you need. And sometimes the recipe doesn't always use the same units. Maybe you only have one measuring device, and so you want to convert everything to work with what you have. Or suppose you're wondering if Usain Bolt could run faster than a car. He ran the 100-meter dash in 9.58 seconds, so you know his speed in meters per second. But your car is in miles or kilometers per hour, so you can't really compare directly. So the question remains, how fast was Usain Bolt in miles per hour? We're going to find that converting between units just involves multiplying by the number 1. So let's remind ourselves what that means. We know that multiplying any number by 1 leaves that number unchanged. For example, 5 times 1 equals 5. We also know that any fraction that has the same denominator as the numerator is equal to 1, since that is just a number divided by itself. For example, 2 divided by 2. Or 100 divided by 100, or even pi over pi. And of course, we can multiply a number by as many ones as we want, and we're still left with that same number. So how does this help us with unit conversions? Let's start with something many of us already know, that 1 foot measures the same length as 12 inches. Since these two quantities are the same, that means that 12 inches divided by 1 foot is equal to 1. They're the same value. Can we use this now for our unit conversions? Suppose I want to know how many inches are in 3 feet. We start by multiplying 3 feet by 1, since we know that multiplying by 1 doesn't change what 3 feet represents. Now let's rewrite that 1 in a more helpful way. We want to cancel out the feet in 3 feet, so we're going to write 1 so that there are units of feet in the denominator, and then we'll put the equivalent value in the numerator, which is 12 inches. Now we can cancel out the units of feet, and the only units we're left with are inches. Once we're left with only one set of units, we can multiply and divide all the numbers, and we're left with 36 inches. So by multiplying 3 feet by 1, we showed that 3 feet is the same as 36 inches.
Now that we've got the basic idea, multiplying by 1, let's brainstorm some of the ones we know and build a library of ones. Note that for each of these terms, the numerator and denominator measure the same thing, just different units. All of these numerators and denominators are equivalent, so we can flip them and still have a library of ones.
Let's take a look at our earlier example with 3 feet. How many centimeters are in 3 feet? Because we have to convert feet into inches and then inches into centimeters, we need 2 ones. Our first one we know from our earlier example, 12 inches over 1 foot. Remember that we need the feet to be the denominator to cancel out the feet in our starting value. The second one should get rid of the inches from the first one, so all we have left is centimeters, the unit we need to answer the question. There are 2.54 centimeters in an inch, and the inches we want to cancel out are in the numerator, so our second one should be 2.54 centimeters over 1 inch. Now let's cancel. First, the feet in 3 feet and in the denominator of our first one will cancel. Then we can also cancel the inches from the 2 ones. This leaves us with 3 times 12 times 2.54 centimeters. After we multiply these together, we get our final answer, 91.44 centimeters.
Let's work through a unit conversion for area. Suppose I want to find how many square inches are in 455 square centimeters. Since we are working with square centimeters, or centimeters squared, we will need to cancel out both of the centimeter units. Squared centimeters really means centimeter times centimeter, so we will need 2 ones that have centimeters in their denominators. We know that there are 2.54 centimeters in 1 inch, and since we are looking for inches squared, we should multiply our original value by the same conversion factor twice. We can cancel out the centimeters, leaving us with inches times inches, or inches squared, which is what we are looking for. After doing the math, we get our final answer of 70.46 square inches and 455 square centimeters.
Now that we've tackled area, let's move on to the third dimension, volume. Say I have 1,000 cubic centimeters, or centimeters cubed. How many cubic feet, or feet cubed, is that? In our last example, we were working with 2D. That meant our units were squared, and we had to cancel out both units. The same concept applies to 3D. We will have to cancel out 3 sets of centimeters. Also, we're going to have to convert from centimeters to inches, and then from inches to feet. Let's do this conversion now to simplify our math at the end. We want our simplified conversion to have centimeters on the bottom, to cancel out the centimeters in our original measurements. We also want our simplified conversion to have feet on top, because feet is the measurement we're looking for. To get feet on top, let's turn our 1 into 1 foot over 12 inches. Now we can multiply our 1 by another 1 with centimeters on the bottom to cancel our original measurement. We also want to cancel inches. Inches is in the denominator in our first one, so we want it to be in the numerator now. So our second one should be 1 inch over 2.54 centimeters. We can cancel inches from both fractions and combine the two with multiplication. This will make our calculations easier later. Let's plug our simplified fraction back into our original setup, replacing all 3 ones so we can cancel all 3 centimeters in the original measurement. Now, all that's left is the math, which tells us that 1,000 cubic centimeters is equivalent to 0.0353 cubic feet.
The last few examples have dealt with length, area, and volume. Let's try to convert between units of measurement for speed. We want to find out how fast 65 miles per hour is in meters per second. To do this, we will need 4 ones. We know that there are 5,280 feet in 1 mile, and since we want to cancel out the miles in the numerator of our original value, we can put miles in the denominator of our first one. However, we aren't looking for feet per second, so we will need another 1. By putting 3.28 feet in the denominator, we will be left with meters, which is our desired unit. Next, we want to convert the hours in our original value to seconds. We know that there are 60 minutes in 1 hour, and that we can cancel out the hours in the denominator by placing hours in the numerator of our next one. Again, we are looking for seconds, not minutes, so we will need a final 1 to complete the conversion. By placing minutes in the numerator of this one, the minutes are canceled out and we are left with seconds. After canceling out all of the units and multiplying our original value by our 4 ones, we're able to find that 65 miles per hour is approximately 29.06 meters per second.
So, does Usain Bolt run faster than a car? Try it out yourself. Think about how many ones you'll need in order to convert his speed from meters per second to miles per hour and how you will cancel out the units. If you've been paying attention, you might have a pretty good idea where to start. If you want to test yourself, try some of these unit conversions and post your answers in the comments, or post some of your own unit conversion challenges. Good luck!